before I start, let me say a few words about homework assignment. Yeah, I just posted homework assignment number 2. And give you a little more than 10 days to complete it. Today, 16th. The deadline is 26th. Yeah. It's slightly more than 10 days. Yeah. It should be enough. Yeah. So after that, then we do midterm. Yeah. So the deadline of this homework assignment number 2, end of Sunday. Yeah, because 26th, that's Sunday, end of Sunday. Then, next week, Thursday, October 30th, that's our midterm here in class. Yeah. Later, yeah. First, let me finish part D. I feel I will have 10-something minutes. Then I will talk about homework assignment and midterm a little bit. The format, okay? The specific format you will see in the midterm. Yeah. All right, let's continue. This table join topic. Join 2 tables. And in our second homework assignment, we will have still 10 query questions. In these 10 query questions, we will mainly practice how to join 2 tables. Yeah. Using 2 databases. One is the Northwind, Microsoft Northwind database. The second one is the company database. Yeah. These 2. Yeah. All right. Yeah. So from this example, you can see we need to use these 2 tables to collect information and combine them in a well-organized way. Then we can retrieve the required data. Yeah. So that's the table join requirement. Yeah. Now let's understand how to join these 2 tables. Yeah. First, from the syntax, it's pretty straightforward. Yeah, first, let's look at the syntax. After that, we need to understand at the bottom level the foundation, theoretical foundation of the table join. Yeah. All right. So here, but when we join 2 tables, we need to remember what we are doing is the relational DBMS, relational. So we need to consider the relation between these 2 tables. There is a special relation. So we need to catch that special relation. Here, the relation is this. This is the relation. Yeah, key relation. What's that? D, so here. Later, we will call, so here you can see employee table, we will use capital E represent later. We call this alias. Yeah. In this alias way, we can, we do not need to write the full name of the table. We just use a short way to write a table, refer to the table. Department D, so D number, department number, this field name in the D table is the same as the Dino. Yeah, there is another field in the employee table. Yeah, each employee belongs to certain department, but so here you can see in this database, the designer intentionally changed the field name. So the same object, department number is an object, right? The same object, or you call property. Yeah. The same property, when it is in different tables, its name is different by, so this change is intentionally used by the designer. Okay, designer intentionally changed. Yeah. So the reason is very simple. The reason is avoid confusion. Avoid confusion. So that's the, straightforward reason. Why avoid confusion? Think about what would happen if we use the same name, D number, same name. Then a lot of confusion. When people talk about D number field, then they will ask you which table you are talking about, right? Because in employee table, there is a D number. In the department table, also D number. Same field name, then confused. Yeah. But if you change the field names, intentionally change the field names, okay, Parmendra join us. All right, yeah. There, no confusion, right? Yeah, because name is different. Yeah, yeah. All right. So here, we need to establish the relationship. Okay? You need to pass this information to the DBMS. So the DBMS, because based on this equality, DBMS knows how to join these two tables. Okay? Yeah. Next slide, I will go to the, inside of that DBMS to explain how does DBMS join these two tables based on this equality. Yeah. All right. So next, join condition. Yeah. So we use this we call a join condition. This is a condition. So we use it as the join condition. Okay. It combines two tuples. Yeah. Yeah. Right. Two tuples. Yeah. So here, what two tuples, right? Yeah. It combines two tuples. Yeah. Yeah. Next slide, we will see that. Two tuples, one tuple from the first table, employee table, second tuple from the department table. We need to join. How to join? We will join tuple in one tuple in employee table, one tuple in department table. Then we join them. Okay, that's the way to join. Yeah. So in next slide, we will see more details to understand how to combine two tuples. Okay, all right. One from first table, one from the second, whenever their values are equal, whenever this inequality holds. Yeah. Because when you join two tuples, many times the corresponding values in these two tables are not equal. If they are not equal, throw away. We don't take them. Throw away. Only when this condition, this join condition, is satisfied, then we take them. Yeah. So that's how to use the join condition. Yeah. All right. Based on this understanding, now let's look at the solution. How to write a query statement for the given question. Yeah. All right. First, two tables in the from clause. Two tables. Yeah. Employee, department. Yeah. All right. Here, although you see we use uppercase, but actually these are table names, right? Yeah, it's not necessary, uppercase. Yeah. We know we like to write the SQL keywords uppercase. Yeah. But they're not SQL keywords, right? They're table names. Yeah. So it's not necessary. Yeah. Uppercase, lowercase, yeah, any version is okay. All right. Here you can see the field names, we do not change the case because for the field names, it's case sensitive. It is case sensitive. All right? You cannot change the case. Yeah. Yeah? All right. So then, where condition. Yeah, where clause. Yeah. Select from where. Yeah. In the where clause, we need to specify two conditions. One is the join condition. One is join condition. Okay, this is join condition. Right? Yeah, we already talked about it. But the second condition, selection condition. Yeah, research department. Actually, yeah, it's not good. Yeah, why I write it uppercase? Because here, not uppercase. Yeah, yeah, and this is the data, right? Data is case sensitive. So if I change, that means I change the data. If I change the case, I change the data. Yeah. So this may not be correct. Yeah. Because we need to use the, original stream value. The stream value is case sensitive. We should not change its case. Yeah. All right. So this should be changed. Okay. All right. So then, here you can see two conditions. Join condition and the selection condition. So then, you run this query statement, you'll get a query result. Pretty straightforward, yeah, the syntax. Yeah. Later we will see, for the same table join operation, joining two tables, there are many versions. Yeah. So you will see there are several versions people can write. Yeah, same thing. Yeah, but different versions based on different logic. Yeah, because here, when we write a query statement, two things important. Yeah. One thing I mentioned last time, performance. We want this query statement runs very fast. That's the first consideration. Second consideration, readability. Readability, easy to understand. Yeah. When people read your query statement, yeah, because they need to use the logic to understand. What do you want to do? So readability is also important. These two considerations. Yeah. But when we talk about readability, for different people, their understanding of readability could be different, right? Yeah. Some people like this kind of logic. Some people like a different way of logic. That's possible. So different people, they have their preference in writing the same SQL statement. Yeah. All right. Another thing, yeah. So here, here you can see we use the aliases, right? D and E. But here we drop the aliases. Okay? I do not use D.D number and E.D no. Yeah, that's okay. For the example here, if we drop these two aliases, there is no confusion for the DBMS. Yeah. Why we use aliases? Because we want to help DBMS avoid confusion. So we want to avoid. So we want to, provide aliases. Yeah. So what kind of confusion? Yeah. Think about if these two field names are the same, both called D number, then if you do not use aliases, DBMS get confused. Which D number I should use? Yeah. So then you use aliases, yeah, then no confusion. Okay? Yeah. So that's the first purpose, using aliases, avoid confusion. Okay? Yeah. But here, even if you do not use aliases here, when you say D number, because there is only one field called D number in these two tables. In these two tables, when the DBMS goes through all the field names, only one is called D number, no confusion, right? So that's why we do not need to put a alias. In these two tables, going through all the field names, only one field is called D-null. Then no confusion for the DBMS. That's why if we omit aliases, see, no confusion, no problem. DBMS can figure out easily. Yeah. All right, so that's another question. But third one, even if we have this kind of understanding, but still, in this situation, when people write the query statement, most people prefer to put the aliases there. Okay, yeah, D dot D number, E dot D number this version is better than this version. Okay, why it's better? Remember, I mentioned that readability issue. Because this version, we have better readability, right? Yeah? When people read this query statement using this version, they know this D number comes from department table. Right? Better readability. But read this version, which table contains this? Because people couldn't memorize, right? Hard to memorize. Which one? Does it come from employee table? Right? Does this one come from department table? You know, for the programmers, they get confused, right? Yeah. So based on the readability issue, this is a better version. Not for DBMS. For DBMS, there is no confusion. But for programmers, there is a confusion, right? Yeah. So this version, yeah, although there is redundancy, right? So when you put the aliases, it's redundant. Yeah. But redundancy is not a bad thing. Yeah. Because when we use the redundancy, if it can help us improve readability, then it is worth it, right? Yeah, because readability is more important than removing redundancy, right? Yeah. So that's another level of understanding. Yeah. All right, next. Next we need to understand the theoretical foundation of this table join. Yeah. Yeah. Because in that way, when you write your own query statement, because you have that foundation in your mind, so you can do a lot of things in a creative way. Yeah, because many times you need to change something. Yeah. When you have the theoretical foundation understanding of that, then so you can make a lot of changes. Yeah. All right. Next, yeah. Understand table join. Yeah. The theory. So there is some special theory behind it. Yeah. More than one. Yeah. So here, first let's understand two table join. Yeah. Then, after we understand two table join, similarly we can understand three table join and more table join. All right. We need to use a math concept. This cross-product concept comes from math. Set theory. Set theory, there is a concept called cross-product. Yeah. So here we borrow the concept from math when we do the table join. Yeah. How to join two tables? We treat two tables as two sets. Two sets. Later, we will change to multi-sets. Yeah. First, in our first initial understanding, let us use a simpler version, set version. Set version is simpler than multi-set version, right? Yeah. But after we understand the set version cross product, then we change to multi-set version later. Yeah. All right, let's use the set version first. Yeah. How to combine the tuples from two tables. Yeah. All possible here. Cross product gives us all possible tuple combination. Why? Yeah. Let me recall the concept. Cartesian product. Yeah. Cross product, Cartesian, same thing. Okay. Cartesian product. Its formal name. Yeah. In set theory, a Cartesian product is a mathematical operation that returns a set from multiple sets. Yeah. Kind of join way. Yeah. Although in math we do not call table join. Yeah. In math we do not call table join. Yeah. So no such concept in math. Yeah. But the way to combine them, yeah, when we do table join, we use the same way to combine them. Yeah. All right. Let's use the symbols to represent how to combine the tuple. A set corresponds to the first table. B set, another set, corresponds to the second table. Now we do cross product or Cartesian product. This is just the symbol, okay? Special symbol. Its meaning is the definition of this Cartesian product. Yeah, so this is definition, okay? Another set, yeah. A pair of curly braces, another set. In this set, there are two parts. Yeah. The element in this new set. Now we want to define a new set. The new set contains all the elements in this form, in this special form. Okay, all right. A pair of parentheses around some elements, okay? Yeah. So it is one tuple, yeah, okay? One new tuple, yeah, because this is, yeah, in its form, we get a new tuple. Yeah. How to define this new tuple, okay? Yeah. Two parts. The first part of the new tuple comes from capital A set. We use a little a to represent. This little a, one element in A, but this little a, when we use if we treat capital A as a table, this little a is a tuple, okay? A tuple in capital A table. Yeah, this little a is a tuple, all right? Yeah. Similarly, little b is another tuple in table capital B, okay? Yeah. So the first part, we copy the tuple in capital A table, yeah. Then, comma separated. Second part of the new tuple, second part of the new tuple, we copy little b tuple from the capital B table. Put them together like concatenation, right? Like concatenation, then we have a larger tuple, okay? This larger tuple, we have more components. Yeah. So all these forms, we put them together, yeah, all possible, yeah, because there are many such combinations, right? Many such combinations. We put all those combinations together as a new set. That set is called A cross B set. The Cartesian product from set A and set B. That's the definition. Yeah. Based on math. Yeah. Based on math, but we can easily borrow it from math set theory and use our table join context, yeah, and fit into that framework easily, okay? Yeah. All right, so now next, a concept called cardinality. Cardinality, okay? Cardinality of this new set. That means the number of elements, yeah, because in this set, you have certain number of elements. How many elements are there in this new set? So we call that number cardinality of the set. All right. So the cardinality, we use a pair of vertical bars like absolute value. But here, we do not call it absolute value. Same notation of absolute value. But in this context, because if you use absolute value on a set, it does not make sense, right? When you use absolute value on a number, it makes sense. But on a set, it does not make sense. So people call it cardinality of the set. Number of elements in the set. All right. The cardinality of A cross B equals the product of their cardinalities. Cardinality of A times cardinality of B. That's very easy. You can see it. Because all the possible in this kind of combination, right? All the possible. So the product of these two cardinalities. All right. Extend it, right? So that's the So we already, this is the extension. We already extended. All right. So here. But later we need to extend a little more from set to multiset. Table, because in database theory, a table means a multiset. Multiset means in A table, we allow duplicate tuples. In capital B set, we also allow duplicate tuples. Where we join those duplicate tuples, duplicate copies of the tuples, how do we join them? Right? So there is a question on that. The answer is we use the straightforward way. Here, let me draw a little bit. All right. Set A, suppose this is set A. Set A, suppose there are two duplicate copies. Okay? Two duplicate copies. Let me use, sorry. I need to use R1, R2. Okay? Suppose this R1, R2 duplicate copies. All right. B, there are three duplicate copies. Okay? S1, S2, S3. Okay? But when you join them using that Cartesian product way, R1, S1 you can join, right? R1, S2, R1, S3 you can join. R2, S1, R3, S. So you can join in all these possible ways, but when you join them, you use this kind of understanding. When you do multisets, actually this is the common way people deal with the multiset situation. Although R1, R2, these two rows, they have exact same tuple value. But when you join them, when you process them, you treat these two as two different copies. Although same values, but you treat them as if they are two different copies to separate them. So that's why we use R1, R2 to separate. Although their internal values are the same. Even the same, we just forcefully, we treat them different copies. Okay? Similarly here, three different copies. Then you just join using different copy understanding to join them. Okay? Even if after the join, you can see there are six tuples, 2 times 3, right? 6 copies. These 6 copies have exactly the same values. Keep them. Keep those six values. Now, if you apply Cartesian product on multi-sets, you do that way. Okay? That's why we call all possible ways. All possible way to join the tuples like this. Yeah. So we can extend it to multi-set version easily. Yeah. Yeah. All right. Yeah, because this kind of understanding later, when we talk about set operations, later we will do set operations. Yeah. We use this understanding to do set operations. Yeah. All right. Yeah. So in this way, we can apply Cartesian product on multisets without any problem. Okay. Yeah. Even if, here we only talk about 2-set version, right? Yeah. Joining 2 sets. Can you do the similar things on 3 sets, on 4 sets, any number of sets? Yeah. Using the same approach. Yeah. Yeah. Although it's rare, right? Most of the time, people only do 2-table join. Yeah. Yeah. Then 3-table join, still possible. Yeah. Certain percentage. Yeah. But 4, 5, more and more rare. Yeah. 4 and 5. Yeah. 4 already rare. 5, very messy. Yeah. 5 will be very messy. Although people can still do that theoretically, 4 or 5, you can still use this theoretical background to do, but may not be a good way. Yeah. Yeah. I have some experience before, because when you join many tables, the performance of your query could be significantly slow. Yeah. Yeah. I had that experience before. The performance could be slowed down significantly. That's a bad thing. So you want to avoid it. That's a bad thing. Yeah. Why? The reason is pretty straightforward. Yeah. Here, let me show you the reason easily. A cross B cross C cross D. Yeah. Let me use a 4-table join case to explain. When you join them, what's the cardinality? The product of all the rows in these 4 tables, right? C, D. Okay, yeah. So first, when you do Cartesian product on these 4 tables, it could be a very large table, right? Multiplication, the size increased quickly. So you may work on a huge table, do processing, that's why it's very slow. Okay? Yeah. So in this situation, a better way is, so you do not join so many tables in one statement. Because in one statement, the table is huge. Yeah. A better way is split. Okay? Split, because in that way you can reduce the table size easily. First, you just join the first 2 tables. Okay? After you join first 2 tables, that's not too bad. Then you can apply conditions to reduce the number of rows, right? Apply the join condition, apply selection condition, you can reduce the table size, right? Significantly. Okay? Do reduction first. After you join them, first 2 tables, then do reduction, table reduction. Okay? Then you join CD. After you join them, do reduction. Then, because the table size is reduced significantly, then you only need to work on relatively small tables, right? Yeah. So you avoid working on a huge table. Okay. So then you can do much faster. Yeah. So that's another important thing you need to consider. Okay. Yeah. Although theoretically these ways are equivalent, right? But in the real world applications, the result different, because the response time is quite different. Yeah. One big drawing, you need to sit there waiting more than 5 seconds. Yeah. So based on my experience before, so I noticed why I only joined 3 tables. Why I'm waiting so long? Yeah, that's not acceptable. Then I split. Yeah. So let me join the first 2 tables, then apply conditions, 2 conditions. Join condition selection to reduce the number of rows. After that, then I join the result table with the remaining table. Then apply. They're much faster. Yeah? Yeah. Yeah. All right. Yeah. Next. D.4, digest table join operation. Now we need to understand, after we have the Cartesian product concept, now we need to move to database part, table join in database. Yeah. Look at the process, detailed process, how to join 2 tables in this D.4. All right, digest table join operation. When we join 2 tables, we need, so here, we want to understand inside DBMS, how does DBMS implement 2 table join operation step by step? 4 steps. The DBMS uses these 4 steps to do 2 table join operation. Yeah. All right, let's look at these 4 steps. Yeah. Join 2 tables. Yeah, the first step. Yeah. First step. Join 2 tables with cross product without considering the join condition. Just do straightforward cross product operation. Yeah, we know. Yeah. So the definition, in the previous slide, concatenation way, cross product. That's the step 1. Okay, so you have a large table. Step number 2, this step always works. Because this step you do not apply join condition, right? No join condition is applied. No selection condition is applied. So it always works, always works. Yeah. Okay? Yeah. So don't worry. Yeah. You can always get an intermediate result of this first step. Okay. All right. Then, second step. Now, after that, you have a larger table, right? Yeah? It's a larger table. Yeah. So here, let me draw diagram a little bit before we go to the step by step. Right. Table A. Table A. Table B. Okay. By cross product, remember R1, R2, R3, Rm, S1, S2, Sn. The way, all the possible combinations, right? All the possible combinations. Okay, all right. All the possible combinations. Okay, like that. That's the first step, Cartesian product. Okay, You can always do it. Yeah. Then step 2, you need to reduce the numbers. The first round reduction. First round, you do row reduction. Yeah. So you have so many rows. Yeah. You apply join condition. So, yeah. For each new row on this join table, yeah. Join table, yeah. So you have many rows. You use the join condition to check one by one. Yeah. If the current row satisfies your join condition, you keep it. If for the current row your join condition is not satisfied, remove it. Keep it, remove it, keep it, remove it. So that you have another intermediate result, right? After you apply the join condition, so you reduce, throw away certain number of rows. Yeah, so you do the first round reduction, row reduction. Yeah, so that's step number 2. Then step number 3, you have another round row reduction. Yeah, yeah, yeah. So here there is some, but when you do this, there is imaginary in your mind. Yeah, so in your understanding, because you do understanding in your mind. In your mind, you use some imaginary tuple variable. Yeah. Later we will talk about this tuple variable. It's imaginary. Okay? You cannot see it. You cannot see it. Imaginary tuple variable, you use it to help you understand the operation. Yeah. Okay. Yeah, because each one, yeah. So your tuple variable, what is your tuple variable? Okay? Yeah. You take one representative of this joined table. Yeah. R part, yeah. R sub I, okay? Yeah. S part, S sub J, okay? Yeah. This is a general representative, right? General representative joining 2 tuples in these 2 tables. Yeah. All right, so this is your imaginary tuple variable, this whole thing. So what is, because you want to see the concrete form of the tuple variable. This is the concrete form of your imaginary tuple variable. Okay? Yeah. Otherwise, you feel too abstract. Right? How can I imagine, right? Too abstract. Yeah. So in this form, your tuple variable. All right? So you have a long list of tuple variables. For each tuple variable, you apply join condition to see which one you want to keep, which one you want to delete, remove. Yeah, yeah. So the first round reduction by the join condition. So your tuple variable, so the way you use it, like iterator, when you have a for loop, right? For loop, every time you process the current iteration, right? So you use some special variable working on the current iteration, similar to that situation. This is the current iteration, yeah. Because when we go through all the tuples, it's like a for loop. In this new table, yeah, this is the current iteration. Yeah. That imaginary tuple variable, just like iterator. Iterator, you imagine some iterator variable, right? Special iterator variable. Okay? Yeah, here, this imaginary tuple variable as the iterator concept. All right. So only select those tuples that satisfy join condition. Yeah. All right. Then we need to do the second round reduction, row reduction. We have selection condition. Yeah? So this round, we go through the remaining tuples, yeah, because after reduction, yeah, we only need to work on the remaining tuples. Then go through again like another round for loop. Yeah. For loop on existing tuples. But this time, this round, you apply selection condition on each tuple. Okay? Imaginary tuple variable. Yeah. Then keep it or remove it. Yeah. Yeah. After you complete it, yeah, after this step, almost done, right? Yeah, because we apply all the possible conditions we need. Yeah, almost done, almost there. But there is a step number 4, the last step. Last step, easy. Yeah. Because you need to prepare the query result, the final query result. For the final query result. So all these rows, yeah, the remaining rows, after these 2 reduction rounds, you have certain number of remaining rows, right? Yeah. So for those remaining rows, in the last step, do you want to return all those remaining rows, all the information in those remaining rows? You need to make that decision in your final step, step number 4. What information do you want to generate from those remaining rows? That's step number 4. Projection. Projection. Last class we learned a projection concept. What kind of projection? Because in your query statement, what data, what fields do you want to retrieve the data, right? Yeah. Because in the original question, you only need to return the data for certain fields. It may not be all the fields, right? Yeah. If you return all the remaining rows, that means you return data from all the fields. But the user does not need all the fields. They only need part of the fields. So you need to do projection. The last step, only take the required fields, you return the data. If for those fields, the user does not want those fields, then you don't need to return the data from those fields. Yeah. That's the step number 4. Okay? Yeah. All right. Yeah. Make projection when necessary. Yeah. The last step. Yeah. Simple step. Yeah. So that's the way we use this projection concept. Okay? Yeah. Yeah. Why people use projection concept, right? Yeah. Yeah. So sometimes we need to use this projection. Yeah. So the table join underlying inside DBMS, these 4 steps are implemented to give you the final result. Okay? Yeah. So after you understand this, yeah, later, when you build your own query statement, yeah, because you understand very well internal structure, yeah, so you can do a lot of things based on this understanding. Okay? Yeah. All right. Yeah. Then tuple variable. So this slide, let me explain a little more this concept. Yeah, actually, I think we should have pretty good understanding. Yeah, we use the iterator. Yeah, we have the experience using the iterator concept. Yeah. So here, this concept, yeah, because later, when we need to write more and more complicated query statements, yeah. So in our module 4, we need to do complex queries. Yeah. When we go there, yeah, we need to use this concept a lot, tuple variable concept a lot. Yeah. Because the logic could be very complicated. Yeah. So we need some imaginary object. Yeah. It's some object. So we need to build our query statement based on that object, that tuple variable, imaginary thing. Yeah. Build around it. Yeah. Yeah. So implicit tuple variable or iterator in the SQL query. Yeah. Yeah. Looping over each individual tuple in the table. Yeah. Yeah. Evaluating condition in the where clause. Yeah. Yeah. So here just give you some high level view. Yeah. Yeah. And later when we work on the complex queries, you need to get your experience. Yeah. Yeah. You need to, study many complex examples to help you understand how to use this concept. Yeah. Yeah. At this point, it's still too early, yeah. So we couldn't get a concrete understanding. Yeah. All right. Only those tuples that satisfy the condition are selected. Yeah, I mean, this is like a, general understanding. Yeah, yeah, but in Module 4, we need to have concrete understanding. Yeah. All right, yeah, that's this concept. Yeah. So here you just, your initial understanding. We use this as your initial understanding. Okay, yeah, yeah. Definitely we need to study much more on this concept. Yeah. All right. Next, now I want to use a concrete example. Yeah. Because the D.4, the previous topic, too abstract. Yeah. You do not see any data, specific data, right? Yeah. You see abstract symbols, the ideas. Yeah. So this D.5, we want to see a concrete example. We want to see the data, the intermediate result. Going through those 4 steps, after each step, what's the current table? The form of the current table. We want to see it. Yeah. So that's this one. Yeah, let me see. I need to, give some time. I need to talk about your homework and not homework. Homework already there. Midterm, yeah, midterm and final. The format of midterm and final. All right. Now, concrete example. Yeah. All right. Yeah. So our old example, yeah, we did before, but now we want to see step by step. How our data changes in those 4 steps. We want to keep track of our data. Yeah. 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 All right, from beginning to end. How does it change? Yeah. Yeah. Let's look at in this example. Yeah. All right. So when we start, step 1, Cartesian product, right? Yeah. Table A, the first table, employee table, there are 40 rows. 40, yeah. In the parentheses, 40 rows. Employee department, 6 rows. Yeah. All right. Then, Cartesian product, join them without any condition. Yeah, so here, yeah, I use notation S, T, yeah, little s, little t. Yeah. Now, when we join them, we have a larger table, employee cross department, all right? Yeah. So the fields, you pack the fields. The first part, you copy the fields from the first table. Then the second part, you copy the fields from the second table. Just join them, okay? Yeah. Then the data part, yeah. In the first part, copy S rows. The second part, copy T rows. Yeah. Okay. Yeah. 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 All right. Following certain order. Yeah. All right. So here you can see how many rows. Yeah. The product of 40 and 6, 240. Yeah. Before row reduction. Yeah. So this step, first step, no row reduction. Yeah, just put them together. Yeah. So that's the intermediate result after the first step. 240. Yeah. All right. Then we need to do reduction. First round reduction. Yeah. All right. Notation. Yeah. Tuple notation. Yeah. S part, T part. Okay. All the possible S, T combination. Yeah. In certain order. Okay. All right. Yeah. Then we're ready. Yeah. Yeah. The column. Yeah. The column number. Yeah. So 10 column. Yeah. Actually, S part contribute 10 columns. Yeah. There are 10 columns in employee table. Okay. S part. T part, 4 columns. 4 columns. Yeah. Second table contribute 4 columns. Total 14 columns. 10 plus 4. 14 columns. Yeah. You keep all the 14 columns. All right. Then we move to the second step. Second step, we need to use the join condition to eliminate certain number of rows. Yeah. Apply join condition. Okay. All right. Yeah. So before we apply, we have 240, 14 tuples. Yeah. 14 components. Each tuple has 14 components. So 14 dash tuples. Yeah. All right. Then we apply the join condition. Yeah. D0 equals D number. If this is satisfied, the value, you look at the value of D0 field, D number field. If they happen to be the same, you keep that row. Otherwise, you eliminate that row. Yeah. All right, so this is join condition. Yeah. The result, after you cross out, you can see you cross out 200 rows. Among 240 rows, 200 of them, they do not satisfy the join condition. So you remove them. Only 14 tuples are left. Yeah. After the first round reduction. Yeah. 40. Your current data. Okay. Then you apply selection condition. Okay. Selection. The second round reduction. Yeah. Going through all 40 rows, row by row, checking this condition. All right. Yeah. There. Yeah. This is selection condition. Okay. The result. Only 4 rows remain. Okay? Only 4 of the 40 rows satisfy the selection condition. D name equals research, the selection condition. So after second round reduction, you only have 14 tuples. Yeah. 14 tuples. But the last step, we do not need to produce data from all 14 columns. We only need 3 of the 14, right? Based on the query requirement, only 3 of the 14 columns. So last step, projection. 3 columns, F name, L name, and address. Okay? Now, the data from remaining 11 columns, you don't need. Okay? You don't need copy. Okay? Yeah. So projection, yeah. Then the data, what's the data? Yeah, all right. Yeah, 3 tuple. Yeah, so you reduce, yeah, here, the projection, you reduce from this form to 4 3 tuples. Each one is your projection is 3 tuple. Okay, all right. So that's the data. The final data generated by these 4 steps. Now you can see the concrete data generated. So you keep track of your data all the way from beginning to end, going through all 4 steps. So now you understand. Oh, by the logic, based on your understanding, this should be the final result. Yeah. That's the way you understand the table join operation. Okay? 2 table join operation. Yeah. 3, yeah. If the 3, that it's easy. After the 2 table join, the result you use to join the third one. Do another round, these 4 steps. Although it is quite tedious, a lot of tedious work, but the logic is there, okay? The logic is there, All right, so I hope after this concrete example, so you have a much better understanding, on table drawing, Not very hard, After you get used to it, pretty straightforward, All right, So now you are ready to those 10 table drawing query questions in homework assignment number 2, based on this example, All right, All right, next, I have about 10 minutes. Now I want to explain a few questions. I hope I can, it should be enough to complete a few questions. The first one, I want to explain, there is one question in homework assignment number 2, I want to explain the meaning. So when you answer, try to avoid some common problem. A common problem I saw from my previous semesters. So here I'm talking about a question number 14 of homework assignment number 2. What's that? So here I just give you the meaning. You do not need to really look at the question. The meaning is regarding projection, understanding of the projection. Okay. So that question, we use select statement. When we apply select statement, when we use this star, we mean all the fields, right? All the fields of the table, okay? From some table here, I just use table name, okay? Table name. In that question, I give you the condition. When you apply this one, this projection part, it returns 3 columns. Okay? Then I ask you, how many possible projections can you get? Because I tell you only 3 fields. The number of combinations limited, right? Number of combinations limited. So the number of projections, that's the requirement. Number of projections. But here I want to point out one potential problem, because many students, based on their answers, they have one common problem. I just point that out. Here, in my example, I use 2. How about that? Smaller number. I do not use 3. Okay, 3. You need to work it out. Okay, I do not work on 3 case. So I work on 2 column case to show you the idea. 2 column case. So you have 2 fields. Your table only has 2 fields. Okay, 2 fields. Let me use. I need to use the field name A and B. How about that? You have 2 fields. A, first one I use A. Second one I use B. Okay, all right. How many? Now we need to count the number of projection, right? All right. Here, let me use each projection. Let me use tuple way. Okay, a pair of parentheses, the tuple way, to represent each projection. Projection 1. A, comma B, projection 2, B, comma A, sorry, all right. Single A is a projection, right? Because all the possible projection from this table, right? Single A is a projection, right? Single B is a projection, right? What else? All the possible cases, right? A, no, that's illegal. Because the second part, you need to come from second table. The second table has no A. So A is illegal, okay? BB is illegal, all right? Because first part you must come from A table, but B is not in the first table, okay? Yeah. Then what I said is many students, yeah, the common error is many students also count nothing, empty nothing as a special case of projection. Don't count that, okay? Don't count empty projection because nobody in the real world situation, nobody use that empty projection, right? Yeah, yeah. It's a useless query. Yeah, yeah. So do not count that empty projection. Yeah, yeah. So for 3 cases, yeah, yeah. Only count meaningful projections. Okay, meaningful projections. Yeah, yeah. So that's the point. Yeah. All right. Yeah. Then next, yeah. Let me quickly talk about the question. Yeah. So the midterm, the format of the midterm. Okay. All right. Midterm and the midterm format. Yeah. I want to do this way. Yeah. Separate 2 parts, part A, part B. Okay. Part A, 10 concept questions. Concept questions. Part B, 15 query questions. All right, yeah. But the part A, yeah, because in these 2 parts, part A, I will give it to you online. You do not need to do the part A in class to save your time. Okay, so you can do part A at home, online. Okay, online, but the online as our quiz number 4. Our next quiz is quiz number 4, right? Yeah. So quiz 4 equals part A of midterm. All right? Yeah. Just one assignment counted twice. Okay? Once for quiz 4, once for part A of midterm. To save you some time. Yeah. Then part B, 15 questions you do in class. Okay? October 30th, this class time, 75 minutes. All 15 questions, all query questions. Okay? Query questions based on homework assignment number 1, yeah, regular expressions, right? Yeah, that part. Simple queries plus regular expressions. Homework number 2, join 2 tables. Yeah. So 15 questions, yeah, covering, these 2 homework assignments in 15 minutes. Yeah. Not too hard. Yeah. Okay? Yeah. So that's the midterm. All right? Yeah. Midterm. Yeah. Yeah. So this in 75 minutes. All right? Yeah. So that's the midterm. Yeah. In class. Okay. All right. Then, yeah. So the last minute, let me talk about final, similar. Final, okay, now. Final, we use the similar way. Final, still part A, part B. Okay? Part A, part B. Part B. Part A is still online, all right? 10 questions. Online. Yeah, so I will finish in one minute, sorry. In 1 minute. Okay. Online as quiz 6, quiz number 6. Okay? Yeah. All right. Then part B, 15 query query, but 15 is a complex query. Yeah. Finally, we need to practice the complex query questions. Yeah. Because much harder than our midterm query question. Well, complex, very complicated. Yeah. And because our final, we have more time, right? We have 120 minutes, 2 hours. Okay, yeah. In person, okay. Yeah. Like this, okay? Yeah, 2 hours should be enough. Okay, okay. Yeah. All right, yeah. So that's the, yeah. For the remaining of the semester, yeah, we will do this way.